with me, everybody. It's nice to meet you all. My name's Chantelle. I work at Cohere as a backend engineer, and I'm on the North Tools team. Okay, let me figure out how to flip this. Okay, so today I'm going to share a little bit about North, how North agents use tools, and dive in on my drive, which is North's document retrieval tool. Whoop. Okay, so what is North? North is Cohere's Agentic platform. It's backed by the command models for generation, and it uses our Compass product for parsing and searching. The command models support 23 different languages, and they're optimized for tool use, reg, and citation generation. Compass handles our content ingestion and parsing using the embed model, and then we store documents in a vector database with an index for each source. We then use re-rank for semantic search across our indexes. For connectors, North has 15 internal tools, and that's the area I work on. We build the tool integrations that allow North to gather information or otherwise interact with third-party sources. We also support MCP to enable custom tools built by either our solutions team or our customers. Okay, but how does the model actually use these tools? So we guide agents to use tools by providing information in system messages before user turns. Most of our internal tools are composite tools, which are collections of capabilities that we enable with one connector, like Google Drive, linear, or local files. We provide the model with examples of how to chain tool calls using several capabilities for one connector to achieve a desired final result. Then, when the user sends a request to the model performs a reasoning step, and then it generates one or more tool calls. We then execute these tool calls. We add the tool results to the chat history, and then we perform another model call. Based on these results, the model can choose whether it wants to generate and execute another set of tool calls or respond directly to the user's query. For a concrete example, this could look like, say, the model going to Google Drive to be like, hey, find me a sprint plan, and then going to linear to say, give me all the in-progress tickets for this sprint for this project team. And then finally, it could look like calling the draft email tool in Gmail to send an email to an external team, giving them an update for like when their request is going to be shipped. Okay. Yes, but with all of that, for today, we'll just focus in on the My Drive tool, which is North's way to access. Whoa. Oh, okay.
That's good. That's good.
Okay, cool. Whoa, that's really loud. All right. So for today, we'll focus on the My Drive tool, which is North's way to access a user's local documents. All right, so I've thrown a bunch of explanation at you guys, so let's take a look at how this actually works in practice. As you can see, I'm demoing off my localhost here, so fingers crossed. Okay, so I've loaded up North, and let me go to my default agent. There we go. Okay, so this agent has a bunch of tools attached to it already. So you can see that there's Gmail and, it looks like something's not quite right. Am I connected to the internet? Toki? Okay, so it should be connected.
Yeah.
But I think it might not be. Okay, it's okay. We'll just try to re-auth and see how we do here. If not, we do have a backup demo, but the live one's way cooler. Okay, I'm sorry, y'all. We're gonna have to move to the backup demo, but I will try to show you something live a little bit later. Okay, so As you can see here, but this is an example of us providing like a single user question and then the model choosing to call like a bunch of different connector tools and the capabilities underneath them. We then condense all of the returned information into one answer for the user in the final iteration of the chat loop. So yeah, that's a little bit about how multi-hop chat works. Okay, so diving in specifically on the MyDrive tool, MyDrive is both the set of tools that North uses to interact with uploaded documents and also the larger features surrounding document storage, syncing, and management in North. In order to make a file available for use in North, we provide a central page for users to upload and manage their files from. When a user uploads a file, we first send the bytes for storage in S3 proxy, and then we create a record of this file in Postgres to associate it with the user. Finally, we queue a task to perform the Compass database vector sync step with a callback to update the file status in Postgres when we complete that task. So MyDrive, as a tool, has read, search, and list capabilities. We perform validation on the model-generated tool params, and then we perform that chosen tool capability. So for read, this means using the model-provided document ID, start page, max pages to retrieve up to like a full document from Compass, but we then have to truncate down to the configured max return tokens available for each tool call. For search, we're asking the model to generate a query and optionally a document ID to search inside of. So then we search within the Compass index and we use this filtered list of document IDs that are accessible to both the user and the agent. Listing is just a variation of search where instead of returning long-form document content, we're just returning like short snippets or previews of a given file. So in order for this whole approach to work, we've made an assumption here that we can either fit the whole document into context on a single read, or that the model is clever enough to chain a whole bunch of reads together until it reads the entire document. But if we end up producing like enough read calls that we fill up the entire context window, we then have to start truncating based on the oldest content. So as we move our context window down, we end up losing the first part of the document. So we had to figure out a way to work around this problem so we can have the model understand long documents like manuals and textbooks. Okay, that's where context management for long documents comes in. So to work around this problem, we start with changing what we do when we first upload a document to MyDrive. First, we send the document to Compass to produce a parsed list of document chunks. We then check to see if the text in all of those chunks would actually fit into the retrieval budget for one MyDrive read tool call. If it fits, then that's awesome. We don't have to do anything different. We can just send it into the vector database for storage inside a Compass. But if it doesn't, then we need to make a chat call, and we fill nearly the entire context window of that chat call with the document chunks. We ask the command model to identify which document chunks are part of the table of contents. We then mark those chunks with a flag, so then later on it's easy for us to retrieve them. And finally, we just send the altered chunks to be indexed and stored inside of Compass Vector DB. And then at chat time, when the user sends a chat message, if the agent has access to MyDrive files, we load some document previews into the chat history as a system message to let the model know, hey, here's what files you have access to, and here's how I'd like you to call, search, and read on these files. For documents where we could find a table of contents, instead of loading like just a short preview snippet from the top of the document into that system message, we actually load the table of contents up to a character limit, and then we let the model know, like, hey, please decide what you read from this document based on this document overview that I've given you. We want to guide the model to search for a full table of contents if it needs to, and that it should use that information to identify like chapter headings or section titles, and based on that information, perform specific sub-searches or reads in order to answer the user's query. So this is definitely like a pretty complex multi-hop tool call scenario, and we're asking the model to literally do like search, 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 n number reads. It does work pretty well, but we found that the performance is limited in some of the older models and that it works best with our newest reasoning model. The older models don't produce as consistent tool call results. Okay, let's try the live demo again. Alrighty, so this is my files, and as you can see, I have this reinforcement learning textbook. Let me show you what's inside the file. Okay, so yeah, this is literally just a textbook about reinforcement learning. It's like 500 pages long, and yeah, the last 3 chapters here are neuroscience, applications, and frontiers. So I've already synced this ahead of time into my drive, but let's load up, let's make, a textbook demo agent. Okay, so if we attach the file from my drive to this conversation, we can ask it something like, please summarize in 20 words each the last 3 chapters of this textbook. Okay. So if we expand this, we can see the model doing this reasoning search. It doesn't have the full table of contents, so it's using my drive search with the table of contents flag and the document ID to grab the full table of contents from the textbook. And then it's able to perform another reasoning step in which it identifies, okay, so these are the last 3 chapters, this is what the user is interested in, and then it's performing 3 targeted searches with the chapter titles. And then based on that, it performs a final reasoning step, and there are some summaries. Okay, so this project is definitely pretty new. I literally worked on it like 2 cycles ago, and we just rolled out the first version of long document support. We have some ideas for where I'd like to go next with this, and that looks like a document overview file tool. So that would be at chat time for documents that have table of contents. I'd like to instruct the model to first use this new document overview tool, and it would retrieve a standardized format of document overview for 1 or more textbooks. This tool would use those table of contents chunks that we've already tagged as the input, and then the output is like a JSON formatted table of contents for as many textbooks as you'd like, really. And then that would allow the model to perform standardized searches across many textbooks or manuals or long documents like that. But this approach adds like another hop to this chain of multi-hop tool calls. So before we put this in production, we're definitely going to have to perform some evals to see if this is like a performant approach across multiple different document archetypes. Alrighty, so that's been a little bit about North, document tool use in North, and what I'll be working on next. So if we've got a few minutes, I'd be happy to answer questions. Otherwise, we're hiring. Please reach out on socials.